So far we've been assuming everything goes our way. We've been assuming the sunny day scenario where the operation is complete. Now let's take a look at the rainy day scenario that happens when something goes wrong and we have to deal with errors. And first we're going to start by talking about the difference between handling errors in synchronous code, and then we're going to talk about how to handle errors in asynchronous code, because it's actually quite a bit different. And I'll give you a quick overview of some of the methods that handle exceptions in asynchronous code. So, as you might expect, exception handling is more complicated for asynchronous computations than for synchronous computations. Why is that, you may ask? Well, let's take a look and see. Conventional exception handling for synchronous calls will involve the exception model propagating exceptions up the runtime call stack synchronously when they occur, to be caught synchronously by some part of the code that knows how to handle those exceptions. So let's take a look at an example. Let's say that method 1 synchronously calls method 2, which synchronously calls method 3, which synchronously calls method 4. And all that means is they just, method 1 calls method 2 calls method 3 calls method 4 in a nice little progression, and method 4 throws the IO exception. What will happen in that case is the Java runtime environment will search up the call stack, trying to find an exception handler that knows how to handle that error. And assuming it finds one, it'll be caught in the calling thread. So let's say, for sake of argument, that method 1 catches IO exception, and it does something to clean up whatever it needs to do. We don't really care. Therefore, the key point here is that the thread that calls the method chain is the same thread that can handle any exception that's thrown synchronously. All right, so remember that, very important. Now let's talk about the asynchronous case, where we have a bunch of things running around in the background in pools of threads or a pool of threads, and it does not, therefore, conform to that nice, ordered, conventional call stack model that we saw earlier. So in this particular case, which is actually not too dissimilar from your programming assignment, we're going to get some HTML page asynchronously. When we get the page, we're going to count the images in the page in one background thread. We're going to crawl a bunch of things in another background thread. Then we're going to combine things, either synchronously or asynchronously, in some background thread, et cetera, et cetera. And so when something goes wrong, there's all kinds of threads running. And the thread that kicked off all this stuff has long since gone off to do something else. It doesn't know, it doesn't care, it doesn't really have a way to know that these asynchronous things have gone awry. So let's take a look at an example. We're going to have thread 2 and thread 1. And let's say, for sake of argument, that thread 1 calls method X in thread 2. It invokes it. Now it's running asynchronously. This thread throws an exception. Thread 1 is already in some totally different place. It's calling its own methods. It's doing its own thing. And therefore, when an exception occurs over here, thread 1 has long since given up any hope of knowing anything about it. It's given this thing up and doesn't care, doesn't know what it's doing. Now, of course, thread 1 can still handle synchronous exceptions, but it really can't handle the asynchronous exceptions because it doesn't know about those things. This thing is now on its own. It's off in the wild doing its own thing. OK, so given that as background, let's talk about how exception methods work in Java completable futures. So as you might expect, there's some completion stage methods called exception methods that handle runtime exceptions that occur asynchronously. And there's 3 of them with async variants. And the purpose of all this stuff, of course, going back to our reactive programming principles from the Reactive manifesto, is to make our programs a lot more resilient by handling erroneous computations gracefully and not letting one thing that goes awry cause the whole program to come crashing down. So the non-async variants run in the invoking thread, or the same thread as the previous thread, and the async ones run in some other thread in some other pool or in the same pool. So that's the main difference between those things. So let's take a look at the 3 different categories of methods, whether they be synchronous or asynchronous. So whenComplete, or whenComplete async, takes a by consumer, and it returns a completable future with the result of either stage, of the earlier stage if it goes well, if all things go OK, if it's the sunny day path, or it is going to throw an exception. And it'll handle the outcome of a stage. The behavior is to handle the output whether a result is a good value because there was no exception or an exception. Now, as we'll see when we look at the example, whenComplete just gives you a side effect. It doesn't really change anything. It just gives you a chance to note or perhaps log that something has taken place with respect to exceptions. So its value is somewhat limited. Handle, or handle async, takes a by function, so it's going to take two things, and it will return a completable future with the result of the by function. And this can actually be used to handle the outcome of a stage and return a new value. So if it gets an exception, it can do something different than if it doesn't get an exception. Typically what it does when it gets an exception is it replaces the exception with some sort of default value. We'll show some examples of that later. And then the third and final category of exception handling methods take a function and return a completable future to t. And if an exception occurs, we replace the exception with the result value. So this one basically is called exception masking or exception hiding, which has its pros and cons. The async version of this was added for consistency in Java 12. It was not in earlier versions of Java. We've been using later versions of Java for some time now. If you're stuck with Android, you might not have this, but using exceptionally async is a bit of an obscure use case, so it doesn't really matter that it's not available in all versions of Java. Here's a nice summary of the capabilities of these three categories of exception handling methods. You can read this article to see more about this, but you can see whether they will give you the results for success, results to failure, can you recover from failure, yes or no, can you transform results, and so on and so forth. So this is a nice thing to look at if you ever want to really get a bird's eye view of how these different methods compare and contrast. So that's a quick overview of the exception handling methods. Let's now take a look at an example that makes it a lot more interesting and more clear.